Today we'll be looking at frequency distribution. So we'll just take an example first. So in this example, a teacher gave a short test to his class. So after he gave the test, he now counted the number of students as against the scores they have. So from the table, we can see the mark, then the number of students. So this mark, we represented it with X. I think it's page 21 or 22. So the mark was represented with X. So that is what we call the variable. So while the number of students is the frequency. So that frequency represents the amount of time that particular variable occurs. So that means one student scored 0. So that means this 0 score only happened once. Only one student scored 0. Then for 1, 2 students scored 1. 2 students also scored 2. Nobody scored 3. 5 people scored 4. 6 people scored 5. 8 students scored 6. 5 students scored 7. 3 students scored 8. Then one person scored 9. And if the maximum score is 10, that means 2 people actually scored 10 over 10. So the addition of this number of students will give us the total number of students in that class. So that's what we call the summation of the frequency. So it is represented by a symbol called sigma. So whenever we see this, it means we are adding everything. So if you see summation F, so it means we are doing 1 plus 2 plus 2 plus 0 plus 5 plus 6 plus 8 plus 5 plus 3 plus 1 and finally plus 2, which I think the total, this one is 5, 10, 24, 29, 33, then 35. So that's 35. So that means in that class we have 35 students present. So this one now is the frequency distribution table. But it is also very possible that we are given a lot of data that we can't actually represent in this frequency distribution table. So that's what will bring us to grouped frequency distribution. This one is just ordinary frequency distribution table. Later, when we have a large class and we have large scores, let's say we have 200 people in the class, so it will be difficult for us to be writing the various marks. So that's what brings about grouped frequency distribution. So we use group frequency distribution when we have a large number of variables. So when the number of variables is very large, let's say the score is from 1 to 100, it will be difficult for you to draw 101 columns then and start grouping them. So that's when we now make use of a group frequency distribution table. So we have an example here. If you open to page 22 in the material, page 22 in the material, those online can actually follow too because I have uploaded the material there so they can check. So under grouped, the example is under group frequency. Group frequency distribution. We have various numbers. So I don't think I need to write it again since it is inside the material. So I will just read out the number. So from the example, the following are the marks of 50 students. We have 11, 21, 33, 26, 30, 45, 32, 26, 18, 3, 18, 25, 28, 24, 11, 38, 23, 20, 13, 40, 18, 12, 8, 42, 21, 10. So, and so on like that. I think we have up to 50 numbers. So, from this particular data set given, we can see that the number of variables there is very large, because if we check it, we see that the scores range from 3 to 48. Yeah, so we have 3 like that till we got to 48, because the highest score is 48. So here we will now need to do something called class interval. So to draw the table, we might be given something like that inside the exam or test. So the first thing we need to do is to draw the table. So, and drawing the table, we have the class interval. Class interval. That's the first thing. That's the first column we're going to have. Then the second column is going to be the tag. Then we can now make the third one frequency. That's the number. So the class interval is known as the amount of spread of each classes. So according to the material, it is advisable not to have less than 6 classes and not more than 12 classes. So the total number of classes you should have should range between, okay, let's say the class is C. So C must be less than or equal to 12, greater than or equal to 6. That's what it is. And the class interval is the spread of each of the classes. So you can decide to make use of a class interval of 5. You can decide to make use of a class interval of 6. But all you just have to do is to make sure that it spreads evenly. So for this question now, they make use of a class interval of 6. It's on page 22, 23. So yeah. So they make use of a class interval of 6. So the lower limit of the class, the lowest, is 3. If you check the data set given, 3 is the lowest number. Yes, and what is the highest number there? If you check.
Number is 48.
48. Yes, that's 48. So if we from 3 to 48, how many how many numbers we have, including 3 and 48?
That should be
It should be around 46.
46.
Yes. It should be around. If we are counting 48, that means we are only removing 1 and 2. Yes. So that's just 46. Yes. So here now, they try to divide the classes into from 3 to 8. So from 3 to 8, we have how many? We have 6. Counting 3, we have 3, 4, 5, 6, 7, 8. Yes. Then from 9 to, if we add 5 to 9, it's going to give us 14. Yes. Counting 9 with it also, that's 6. Yes. So the next one from 15
to
to,
21.
if we add 5 to it,
20.
it should be 20. Yes. Then from 21 to 26. Then the next one is from 27 to 32.
Yes.
Then the next one is from 33 to 38. Yes. Then the next one should be from 39 to 44. The last one is
45 to 50.
45 to 50. Yes. So we have a total number of 1, 2, 3, 4, 5, 6, 7, 8 classes, which is still within this our limit. Yes. It should be more than or equal to 6. It can be less than or equal to 12. So it must not pass 12 and it must not be less than 6. Yes. So the next thing for us to do now is to start counting. We now go back to our table. Yes. It might be given as a table, it might just be given as a raw data. They can just list it and be putting comma. So you can just see 1, comma 2, 5, 8, 2, like that, instead of table.
Okay, the class interval will be between 6 and 12.
Yes, the number of classes you have. And you make sure you distribute your class evenly. You can actually start from 1, but if you check the data given, you see that we don't have 1. But at the same time too, if you check the data given, you see that we don't have 50. Yes. So if we are starting from 1 now, that means we are going to use different intervals again, just to make it even. So that means it's going to probably going to be from 0 to 4, or from 1 to 5. 1 to 5 is how many? That's just 5. Yes. Then from 6 to 10, like that, till we also get to 50. That means at the end of the day, we are going to have 10 classes, so which is still within. So the smaller your class interval, the more detail you get by the time you are computing. So for example, let's say we made our class interval from 1 to 10. So by the time we are trying to find out our mean, we are going to, this is an interval. We are no more using a single, the normal frequency distribution. So we are going to have something like a range. So the mean is going to fall within so class. The median is going to fall within so, and the mode like that. So because we already use grouped. But if we increase our class interval, the detail we are going to get is going to be bigger. Or should I put it, the detail we are going to get is going to be more vague, but by the time we narrow it down, the detail is going to be it's going to increase. So for example, let's say by the time we are using the one that has 5 classes, let's say we got our mean as let's say 22.5. We might not even get 22.5. All we are just going to get is that it's between so figure, and that if our mean is 22.5, that means it's between this class. But if we reduce the class interval, we'll still be able to narrow it down more. So, but all you just have to do is to make sure.
Our class interval is not less than 6.
Yes, exactly. So you should make sure it's not less than 6 and it's not greater than 12. So I believe that's clear. Let me just review this marker again. Just so for this one now, if you count within 3 and 8, how many scores do we have? Within 3 and 8, if you count. So within 3 and 8, I think we have 3, 8 and 6. That's 1, 2, 3 for tally. So let's check for from 9 to 14.
9
to 14. I think it has been done already, Sha, but you can just take a look at it and see if there's any mistake. So if you count it from 9, numbers within 9 to 14, if you count it there, you see that we have up to 97. So, and to represent it using tally. So the reason why we make use of tally is so that as you are saying the number, you can be representing it with a stroke instead of counting it in your head that you might forget. So maybe when you see 9 now, you draw a mark. Maybe you see 9 again, you put another mark like that, so that you won't mix it up. That's the reason for you doing that. So if you count it, we are going to have 7 of them. So, and 7 is 1, 2, 3, 4, 5, 6, 7.
No, come again. Just please.
Is it the representation of the tally? Okay. If you want to represent numbers, frequency using tally, to represent 1, just a stroke. Yeah, it has. Don't worry, you don't need to change it. That's bypassed. To represent a stroke is just 1. Another one, which is 2, 3, 4. But when you get to the 5th one, anything divisible by 5. So that one we act like a rope that will tie them together.
Okay.
So anytime you see something like this, it's 5.
Okay.
So you now start counting again in case it's more than 5. Let's say we are going to 9. That's 7, 8, 9. That's just it. So if you want to represent 21 now, that means you are going to have 5 in how many places? 4 places, then one extra one. So
For the first one.
for the first one,
Yes. Three.
yeah, we only have 3. If you count, if you check the table,
Okay, 3 students.
yeah, 3 students, just 3 students has that score.
Carry on.
So between 15 and 20 now, yes, let's check the table and see how many do we have.
7.
7, okay. So that is correct. That means it's going to be the same representation as the previous one. 6, 7. So the next one is between 21 and 26. So that one is up to like 14. Yes.
1, 2.
Yeah. And to make it easier, maybe when you are doing your work, you can hold a pencil
Yes.
so that you can be circling it or cancel so that you can cancel them. You can apply different marks for different classes. And you'll be able to get them.
4, 5, 6, 7, 8, 9, 10,
14.
11,
That's 14.
Yes. Then do the next one.
13, 14,
14, yes. Then the next one.
27.
27 to 32. It's more than that. Then because of time.
uh,
So the next one, if you count, you see that it's 5. Then the last two is 2, 2. So by the time we add everything together, it will give us this plus this plus that's 14 plus 3, that's 17. 17 plus 14, that's 31. 41. 41 plus 9, that's 50. So everything is 50. So if you decide to count those figures inside that table, one after the other, you'll be able to count up to 50. So, and now that we've done this like this, we can now say the value or the class with the highest number of students is which class? If you look at it, which class has the highest number of students?
48.
Yeah, the class with 14. And which class is with 14? Between 21 and 26. So this is what I'm trying to say the other time, that the narrower our class interval, the more detail we get.
What did they say?
Hmm?
What did you say?
I said the narrower, the smaller our class interval, the more the detail we get. So for example, now we are saying between 21 and 26, that class has the highest. So assuming we reduce our class interval to something smaller, we'll have been able to narrow this one two down again to another class. Do you get my point?
Yes.
So
The
that's
highest one we pick now is like the more than.
yeah. What I just did now is the mode. The class with the highest occurrence. That's the mode. That's the simple definition of mode. So from here now that we've understood the two types of frequency distribution, that's what we are going to be using to calculate the measure of central tendencies that we are going to know. So we'll be doing the one for the ordinary frequency distribution, and we'll also be doing the ones for the grouped frequency distribution. So measure of central tendency, measure of position, or measure of central tendencies. So we have like 3. Measure of central tendency is the measure of how data are placed. So they also call it measure of position. So how the data, we have 3 types of measure of central tendencies. The first one is the mean, the second one is the median, then the third one is the mode. So we'll be considering the mode first. So mode is the value of the variable which has the highest number of occurrence. We can get down from the example we just did. So the value of the variable with the highest number of occurrence is the mode. So let's consider this one first. this frequency distribution, which class has the highest frequency? Which mark rather has the highest frequency from this table?
That's eight.
Eh,
Eight
No.
students.
6, yes. 6 is the mode. Is the mark that we are referring to.
Okay.
But we are referring to it with reference to the number. So it's the number we are looking at. This one is the highest. But although it's the highest, which score has this number? That's 6. Yes. Then we've done this one before. For this one now, which class has the highest frequency? Class 21 to 26. So, and there's one thing I forgot to mention the other time. So, for these classes, you notice that it is from a particular number to another number. So, that's what we call the class interval. But the first number is the lower limit, while the second one is the upper limit. So, they can ask you that what's the upper limit of your second class? So, that's 14. While the lower limit of this second class is 9.
Second class.
Yes, this second class. So that's what mode. You don't need to do any calculation to find your mode. You can just look at your table, your distribution table, to get your mode. And you can also use histogram to get your mode. Use of histogram. Mean is also called average. Yes. So the mean is also called the average. So for this question now, this particular distribution that we want to find the mean. So generally, mean, when you have a number of variables, let's call it x1, x2, till we get to xn. The mean is referred to as x bar. That's the mean. It's defined as the summation of all your x. So that's x1 plus x2 plus like that till we get to xn, divided by the total number of variables, which is our n. Yes. So to write it in another way, our x bar equals to the summation of your x divided by n. That's your mean. That's what we call mean. So for this question now, this one is actually a grouped data. This this one is a frequency distribution, not just a raw data. So if you want to write this one out, that means what we are going to have now. If you want to write it in this form, that means what we are going to have is one person had 0, 0, 1, 1, 2, 2, then nobody had 3, then 5 people had 4, 4, 4, 4, 4, 4, then 6 people had 5. Then 8 people had 6. Five people had 7. 3 people had 8. One person had 9, and 2 people had 10. So this particular data, I'm just rewriting it as if it is not grouped at all, as if it is not distributed by frequency, so that we can actually make use of this. So assuming the question is not in this form, assuming it is in this form, there's another way of doing it. So we still go back to that after we are done with this. We now compare our answer whether it will be the same or not. So what we now want to do now, our mean equal to the summation of all the x. Everything here now is a score. So the addition of all the scores divided by the total number of scores. So let's try to find the total number of scores. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. That means in this question now,
Yes. N is like
our n is equal to
35.
35. So the summation of our x now equal to the addition of everything we have here. You do have a calculator so that you can press it. So it's going to be 2 plus 4 plus 20 plus 6 plus 20 plus 26 plus 30 56 56 plus 4 plus 96 plus 8 104 104 plus 30 34 139 139 plus 25 163 So that means our mean equal to 192 divided by 35, which is equal to
Divided by 35. Less than 5.8, 5.485.
5.485. Yes.
Or are we approximately to the
No, you can make it 5.5 approximately. It's fine. So now to the way of doing it in case our data is not given like this. So let's say our data is given like this. So mean is equal to summation fx divided by summation f. That means we still need to draw another thing. So let's call this table max, which is our x. Then the second one is frequency, which is our f. Then the third one will now be fx. That means each mark multiplied by its frequency. So we have 0 here. One person scores 0. Fx will be 0 times 1, which is 0. So for the second one, we have 2. Sorry, 1. 1 first. How many people scored 1? 2. 2 times 1, 2. So for 2 also, 2 people scored 2. That's 4.
Yes, I'm
Three.
calling this one now.
0.
I remember this.
Okay, you remember this one. So for 4, we have 5 people. That's 20. For 5, 6 people. 30. For 6, we have 8 people. That's 48. Then for 7, we have 5 people. That's 35. For 8, we have 3 people. That's 24. Then for 9, we have 1 person. For 10, we have 2. So this one is 9 and 20. So summation f now, if you add everything together, it's going to give us 35. Summation fx, if you add everything here together, it's going to give us 192. So from our formula equal to summation fx over summation f, that is it's equal to 192 divided by 35, which is still the same answer, 5.485. That's the average score. So,
Let me copy this one.
all right. So while you're copying, there's another method called the method of assumed mean. You assume that a particular value should be the mean.
Mark, I think that's mark.
This is the marks. So assumed mean is also known as the working mean. So here now you can just look at the scores roughly. Like, okay, which score can be average here? Okay, let me say 5 is my average score. That means we are picking an assumed mean. So there's a way to estimate the mean also by doing that. So using assume mean, like I said, assume mean is also called the
Wait,
the working mean. So for us to use an assume mean, we just have to assume a particular mean. So through that assume mean, we subtract that mean from each of the variables. So after doing that, we now find the mean of it. So that mean that we find, we call it the reduced mean. So after we've gotten the reduced mean, the original mean now is now the assumed mean plus the reduced mean. So where equal to summation f into bracket x minus c, or x minus m now, let's call it m, over summation f, or for unused data, for raw data. And we now see whether we get the same answer or not. So can I continue? This one is all, yes, all.
N plus
Yes, n plus summation x minus m over n.
S minus
M
minus M
over
over
n.
N.
Yes.
Okay.
So also using this example, or before we go to the example, so from the first formula, which is this, we see that we need to have an assumed mean. Then from each of the variable, we need to subtract that our assumed mean. Then now multiply the result by the frequency, add everything together, then divide by total frequency. So what do we mean by that? So for this question now, this same question, let's still make use of it. So in doing that, I will need to clean a particular column. Yes. Then I will need to add.
is it clean or hard?
I will add one more. I will add one more. Oh, that one that I cleaned said I shouldn't have cleaned it.
Today is 9.
It's today now. Okay.
Yeah.
So according to the table, I think this one is 1, right? 1, 2, 2. How many people are 3? I shall know that this one is 5, this one is 6, this one is 8, this one is 5, this one is 3, this one is 1, and this one is 2. What is this one? For 3?
3 is 0.
0, okay. That's why I did not remember. Okay, so from this question now, that means we should have gotten our assumed mean. So what should we use as our assumed mean? You can assume any number. If you like, you can assume minus 1000. But you just have to assume something you think will be close to the original mean. Mind you, we don't know the mean yet. We don't know the mean yet.
6,
If you assume 6,
7,
you can assume 6, you can assume 7, even if you like, you can assume 10. So from this question now, we can say we should let our assumed mean, let m equal to, what do we agree? What should we use? What should we use? What should we use? What should we use?
Say 7 now.
7, okay. Let m equals to 7. So our m is 7. And remember that in this table, we have x minus m. So that means this one is going to be 0 minus 7 and minus 7. Then 1 minus 7.
1 minus 7, that should be minus 6.
minus 6, 2 minus 7,
-5.
minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. Yes. So we now have f multiplied by x minus m. So 1 multiplied by this will give us what? 1 multiplied by minus 7.
-7.
That's minus 7. Then 2 multiplied by minus 6. That's minus 12. This minus 10. 0. This one is minus 15. This one is minus 12. Minus 8. 0. 3. 2. 6. So all we need is the summation, the addition of n equals to 7. The addition of f and the addition of this one. So our summation f has not changed. Our summation f is still 35, right? 35. Then this one is going to change. What is this one? 7 plus 12. That's 19 plus 10, 29. 29 plus 10, that's 39 plus 5, that's 44. 44 plus 10, that's 54 plus 2, that's 56. 56 plus 8,
56
plus 8, that's 64. 64. 64 minus 3, that's 61. 61 minus 2, that's 59. 59 minus 6, that's 53. So here is minus 53. Yes. And remember, our formula is x bar now equal to m. Our m is what? 7. Plus, well, in this case, it's going to be minus. Plus minus 53 over 35. So 7 minus 53 over 35 is what?
50.
53 over 35.
1.51
What's the something? 1 point
1.5142
285. So let's subtract this number from 7.
That should be 5.485.
So which is equal to 5.485, which is still the same thing as the answer we got before. So you can actually assume any number and it will still give you the same value. So now we'll be moving to finding the mean of a grouped frequency distribution. Alright. So you can be given an assumed mean to work with, or the lecturer can just tell you to assume any mean. So for those that use the direct method and for those that use the assumed mean method, you get the same answer. So let's move on to the mean of a grouped frequency distribution. So for grouped frequency distribution, to get the mean, the first thing to do is to, in case you are given a raw data, what we need to do first is to do the tallying, then knowing the frequency. So like that for my example that we were given, let's write it again. Let's make it as an example. So the first one we have 3 to 8, okay, for the x, which is the mark. We have 3 to 8, 9 to 14, 15 to 20, 21 to 26, 27 to 32, 33 to 38, 39 to 44, and 45 to 50. So the various frequency we had was we had 3 here, 7, 7, 14, 10.
For the tally,
Yeah, we don't need to, yeah, you must have done the tally yourself. So then after 10, what do we have?
5.
5, 2, and 2. Yes. So for us to calculate the mean of this one now, we need to do, we need to what's it called? Compute the class centers. Class centers. Class center. So for the class center of this one, what you have to do is to add these two together, the lower and the upper limits, add them together, then divide them by 2. So if you add these two together and divide them by 2, what we have? That's 11 over 2.
yes, 11 over 2.
That's 5 and a half. Yes. Then this one is 23 over 2. That's 11.5. Then this one is 35 over 2.
15, 17.
Yeah. Is it 15 or 17.5?
25.
Yeah. So 21 plus 26, that's 47 over 2. That's 23.5. Yeah. 23.5. We see that everything is like everything is has something that is increasing. It's this one plus 5. No, is it plus 6 plus 6 plus 6? Then this one plus 6, that's 29.5. Then plus 6 again, 35.5. Then plus 6 again, 41.5. Then lastly,
47.
so let's see whether we're correct. 95 divided by 2.
95 divided by 2, that's 47.5.
Yes. Okay. So we can say this one is kind of like correct. So for us to get the mean of this, it is the same as the summation fx over summation f as usual. But in this case now, our x is a class interval. So, but now we've gotten a class center. So we can as well change this one to C, to center. Yes. You can write it as summation fx, fine, and use this one. And you can also write it as summation fc. So anyone you like. So what you just have to do now is you multiply this one by this one. If you multiply 5.5 times 3, that's 11 plus 5.5. 5.5.
That's 16.5.
Okay. Then the second one, 11.5 multiplied by 7. 11.5 multiplied by 7.
80.5.
80.5. Then 17.5 multiplied by 7.
That's 122.5.
122.5. Then the next one, 23.5 multiplied by 14. 23.5 multiplied by 14.
390.
390.
329.
329. Okay. So this one is 295. Then this one is 355 over 2. Or 35.5 times 5.
177.5. 7.
173.
No.
177.
Yes.
Then this one, this one should be 80, 83.
Yes.
Then this one is 95. 95. Yes. So adding everything together now. Our frequency here is 50. Is it 50 or 35?
Should be
I think
35.
35. Abi?
Okay.
Let's do it.
Let's check.
This is 10, 17, 17 plus 14. Oh, this one should be 50, not 35. It should be 50. Because this is 9. 9 plus 10, that's 29. 29 plus 14. 29 plus 14, that's,
30.
yeah,
30.
that's, is it 30?
19 plus 14. That's without 4.
Okay, 19 plus 14, yes, that's 30,
7.
33. 33 plus 10, 43 plus 7, that's 50. Yes. So addition of this one to FC.
4. That was.
So we are, you have calculators. Everything. FC, I did FC together. I think if you give us, is it 10, 20? 10, 20.
Is that 329?
Which one? Yeah, 329. One one nine. 1199. Okay, so this one becomes 1199 divided by 50. What do we have?
23.9.
23.98. So we still confirm whether our answer is correct or not. We confirm. So that 23.98, we have to keep it somewhere. Then, we've done this one now. Then there's still another one using the method of assumed mean. Now, this one is direct mean method, but we can also use assumed mean.
That's 1,000.
1,299. Or you can use FC. You can use this one as summation FC over summation F. Yes.
So that's our mean now.
Yeah, that's our mean. So this one now, I want us to use an assumed mean of 20.
One.
The way we did it.
So that we will now check whether if we now get our reduced mean to be 3.98, that means our answer is correct. But if we not get our mean to be 3.98, that means there's something wrong somewhere. So I think for us to use the assumed mean, we need to add extra. It's still the same thing as this, but we just need to add another column before we finally do FC.
Okay.
So
That's what happened.
yes. So assuming you can write assuming on top of it.
No, 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 no. It's a class setup.
Hey, I know.
I will not managing class and talking.
C. I'm still going to do
Okay. I
C
get
minus M.
I was thinking you want to change that column to 30 minus.
No. C minus M. And you are still going to have F C minus M.
So our M should be 20, no?
Yes, our M should be 20. So M equals to 20. So far, our C minus M, that's 5.5 minus 20 is what? 5.5 minus 20.
That's 14.5.
Minus 14.5.
Yeah, minus 14.
Okay. 11.5 minus 20. 11.5 minus 20.
Minus 8.5.
Okay. So this one should be minus 2.5. 17.5 minus 20.
Minus 2.5.
Okay. 23.5 minus 20.
3.5.
29.5 minus 20. 29.5 minus 20.
9.5.
Okay. 35.5 minus 20.
15.5.
Okay. 41.5 minus 20.
41.5 minus 20.
Mm.
21.5.
Okay. 21.5, sorry, 47.5 minus 20.
That should be 27.5.
Okay, thank you. So our F multiplied by C minus M now. Okay, I think we already know that this is going to be 9.5. Then,
Multiply by F.
yeah, multiply by frequency. And this one is going to be times 2, 7 times 2, 749. Okay. So let's see.
9.5 is 95.
95, sorry. Yeah. So 3 times minus 14.5.
I'm coming. I'll start from the below.
You are starting from below, okay.
55.
27.5 times 2, 55, right? Then next,
21.5 times 2. 43.
43. Then 15.5 times 5.
Whoosh.
You went to do times 2.
Times 5.
Is what?
77.5. 77.5.
Then the next one is 3.5 times 14.
Come. 3.5 times
Should be 49.
49.
Okay. Then minus 2.5 times 7.
2.5 times 7.
Mm.
Minus 17.5.
Minus 17.5. Then minus 8.5 times 7.
Minus 59.0. Minus 59.5.
Let's get 0.9. So minus 14.5 times 3.
Minus 43.5.
Minus 43.5. So let's take the summation. The summation F has not changed. The summation F into C minus M that we are looking for. So please
Don't
calculate.
pick that M.
That?
I say our M is the one we pick.
Yes.
So we now subtract each of C
From here.
That's minus 43.5.
minus 59.5 minus 17.5 plus 49
199.
199.
25, 77 point.
Okay. So
Plus 43, 55. Am I correct? 199.
so that's 20 plus 199 over 50, which is what? 20 plus what? 3 point. 3 point what? Uncle Bro. 199 over 50. That's 3 point what?
3.98.
So it's actually correct. So our mean now is equal to 23.98. So you see that it's the same as the answer we got before. So that means our calculation is correct. To get our median, especially for a raw data, for an ungrouped data, what we have to do is to arrange the variables in order. Then, the page number
No, 28.
28. Okay, thank you, sir. Page 28 on the material. So to get the median for an ungrouped data, we have to arrange the set of variables according to order, to increasing order. Then we know the total number of variables.
Yeah, it's the minimum number.
Yes. So we can know the total number of variables by counting the number of variables we have, and their occurrences. That's the frequency, summation f. So dividing summation f by 2. So for example, let's say we have a set of ungrouped data that occurred in total in 50 places. So that means we have to arrange those numbers in that order. Let's take this simple example. So the first thing we need to do to find the median of this number is to count the total number, or to rearrange the numbers according to the order. So we start from the lowest. So the lowest we can see here now is 1. So how many ones do we have? We have 1, 2, 3, 4. So that means we are going to say 1, 1, 1, 1. We are done with 1. So which number is next to 1? That's 2. How many do we have? 1, 2. Yes. So 2, 2. So the next is 3. How many do we have? Coincidentally, we also have 3 in 3 places. 3, 3, 3. Do we have 4? No. Do we have 5? Yes. Oh, we have 4. Yeah. Sorry. Then 5. How many do we have? 2, 5, 5. What about 6? We have 1. 7? No. 8. We also have 1. Do we have 9? Yes. 1. So let's count the total numbers that we have and compare with what we've arranged. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's count these ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So, yeah, we are good to go. So, the median is the number at the position where you divide your total frequency into 2. So, if you divide our frequency into 2, here now, 15. So, 15 divided by 2 is what? Is 7.5. 15 divided by 2 is 7.5. Yes. So 7.5. So the number at that midpoint. So that means if you divide it into 2, that means you have 7 on this side, 7 on this side. We now have 1 at the middle. Yes. So that's it. So let's count. 1, 2, 3, 4, 5, 6, 7. So the 8th value here is our median. That's it. So let's say for example, the numbers we have, they are not odd, they are even. That means, okay, let's add one figure to it.
Nine.
Let's add another 9 here. Yes.
It will be between 3.
Yeah, it's still going to be between 3. So let me change this one to 4 so that we can just spice it up a bit. So for this particular one now, we now have the total number of variables to be 16 as against the 15 that we had in the first time. So for this one, you count. Where is the middle of that 16? 8. So that's in between the 8th and the 9th variable. That's 1, 2, 3, 4, 5, 6, 7, 8. So that means in between 3 and 4. That's where we have our median. So, and if we have it like this, how we go about it is to add the two together, then divide by 2. So our median now equal to 3 plus 4 divided by 2, which is equal to 7/2. That's 3.5. That's our median. So sometimes we might be given a group data. So let's take this example. The number of eggs laid by a chicken each day is counted over 15 days as shown in the table below. Find the median of the eggs. The median of the eggs. So the first way to do it is to list out everything. Now we are given the variable and we are given the frequency. So that means for 0, we have 0 in one place. Then, according to the table is also inside the material. We have 1 in how many places? 2 places. 1, 1. Then we have 2 in 4 places. 2, 2, 2, 2. The next one is 3, 5. 3, 3, 3, 3, 3. Then we have 4 in 3 places. 4, 4, 4. So how many do we have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that means it's the 8th one. 1, 2, 3, 4, 5, 6, 7, 8. So that means the median of this now, our median, is equal to 3. So 3 is the median number of eggs. And there's another way to do it. Another way to do it is to draw the distribution table. Since we know that we've been given our variable and various frequencies, so we can just draw the table. This one x represents the number of eggs, while f represents the number of days. So we have 0, 1, 2, 3, and 4. So for day F, there was 0 eggs in one day. There were 1 egg in 2 days. This one is in 4, this one 5, while this one is in 3. So what we need to do next to determine our median is to find the cumulative frequency. Cumulative frequency, which is CF. Or you can write it in full, cumulative frequency. So this frequency, since this is the first one, we just write it outside here. It's not there, it's not in the material. It's not in the material. So for the second one, you just add the next one to the previous one. That's 2 plus 1, making 3. Then The next one, 4 plus 3, 7. 5 plus 7, 12. And lastly, 3 plus 12, 15. So the last frequency you have on this cumulative frequency column must be equal to your total frequency. It must be equal. So what to do now is to now take the last one, which is still the same thing as the total frequency, and divide by 2. So if we divide 15 by 2, we have 7.5. 15 divided by 2 equal to 7.5.
Why do you have to do that calculation first? Is it compulsory?
No. But yeah, it's not compulsory. But what if you have up to 500 variables? So once we've gotten 7.5, you now look at the number where you can get this 7.5. Looking at this one, we have 1. Here we have 3, which is still not up to 7.5. Here we have 7, it's not up to 7.5. But before we reach 3 here, like between this and this, so we can say 3 started from 8, or it started from above 7. So that means it is after this one that we can get this 7.5. So our median here is going to be this. So this is the reason why we need it, the cumulative frequency, so that we can know where this is going to fall. It's just, there's no formula. Just add your previous frequency to your next frequency to the previous one. So here now, 1 plus, there's nothing before 1. 1 plus 0, 1. 2 plus 1, then 4 plus 3, 7. 5 plus 7, 12. 3 plus 12, 15. So, is it clear?
Yes.
Okay. So the last part is the median of a grouped frequency distribution. The median of a grouped frequency distribution. So the first one is for group data. The second one that we did is for a group data. No, it's not like group data, but it's a frequency distribution data. So the next one is a grouped frequency distribution. This one is on group, is raw data. This one is an ungrouped frequency distribution. But the third one we want to go for is the group frequency, the one that has a class interval. That's the last part that we want to go into. So we're taking an example. So we were given a table, and the class interval, we have how many classes? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 classes.
You can just use that for my example.
Then we have our cumulative frequency. Then this one is 3 to 8, 9 to 14, 15 to 20, 21 to 26, 27 to 32, 33 to 38, 39 to 44, 45 to 50. Yeah. And for the frequency, 3, 7, 7, 14, 10, 5, 2, 2. Yeah. So here now the cumulative frequency, there's nothing before this one. That's 3. 3 plus 7, 10. 10 plus 7, 17. 17 plus 14, 1. That's 31. Then this one gives us 41, 46, 48, then 50. So like I said, the total must be, the total must be equal to the total frequency. The last cumulative frequency must be equal to your summation here. Yes. So here now 50 over 2. 50 divided by 2 is equal to, sir?
25.
Yeah, 25. So from here, where can we get 25? That means it's after this group that we can get 25. So it's between,
21.
yeah. So the median class now the median class equal to 21 to 26. Yes, but that won't stop there. It is not going to stop there. So we can see that for that particular class, it stretches from, like, if you take the class boundaries, it stretches from 20.5 to 20, yeah, from 20.5 to 26.5. Oh, I've not explained class boundary. So for the sake of drawing the histogram, you need to take class boundary. And class boundary is your lower limit minus 0.5, your upper limit plus 0.5. That's class boundary. You get? So that means if you are to take the class boundary of this one now, it's going to be 2.5 and 8.5. The class boundary of this one is going to be 8.5 and 14.5. You see that the last figure here is now the same as the last figure here. Because if this one is 2.5, this one is 8.5. If you subtract 0.5 from this one again, 8.5, 14.5, 14.5, 20.5, 20.5,
So now
26.5.
2.5 now will not be the line.
Yes, that's the boundary between them. You understand? Yeah. So you notice that this is our particular class, 21 to 26. It stretches from 20.5 to 26.5 at an interval of, what's the interval? Like, if you check the interval, how many distances are between them?
Basics.
Is it 6?
8.
No, I just, how many, or what's the interval? Yeah, it should be 6. Yes, it's 6. And it contains how many values does it contain?
14.
No, 8. Abi?
That's between 21,
Yeah, it's
20.5
14.
and 26.5.
Yeah, it's 14.
The highest F.
Yes, it's the highest F, but it doesn't mean it's that it is the one with the highest frequency. Doesn't mean it is the one that must be the median. It's not compulsory at all. So
Wait, what is that?
I'm asking that what is the like how many this thing?
The median frequency of that class.
Yes, I'm asking for the frequency of that class. Like, it contains how many values? It contains 14 values. Yes, it is the mode, but it is that same class too that also contains the median. But what we want to do now is to estimate. It's not going to be the correct answer because this particular value is going to vary from class interval to class interval.
20.5 to 26.5.
Yeah. So we said the other time that our this thing, the median, is going to fall on 25, and here now we have 17. How many numbers do we need from 17 to reach 25?
8.
That's 8. Yeah, that's 8. So that 8 now, we now use it to divide the total number of values inside that class.
8 divided by 14.
Yes. Now use it to multiply it by the class interval, the range from here to here.
14 divided by 8.
8 divided by 14.
8 is going to be 8 divided by 14 multiplied by 6.
That is 25 minus 17.
Yes, minus 17. Then that 14 is the frequency of that class. Then that 6, it is the class interval. So what do we have?
0.5714.
0.
5714.
Okay.
Correct.
So that 0.5714, we will now add it to from the boundary, we add it to the lower boundary. This one is 3, this one is 7. That's 24/7. You said it's 0 point. It shouldn't be 0 point. It shouldn't be 0 point. It should be about 3 point something. It's 3 whole number, 3/7.
It's three.
It's 3.4.
3.428.
Yeah, equals to 3.428. Yes. So this 3.428 we now add it to our median now, our estimated median equal to 3.428 plus this lower class limit, lower class boundary, sorry. The class limit is 21 for the lower, 26 for the upper, but for the boundary it's 20.5 for the lower and 26.5 for the upper. So plus the lower boundary now, that's 20.5. So which will be equal to what? And mind you, for a grouped frequency distribution, the mean we are getting is an approximate value. So if you decide to tighten this your class interval, you will still get something more close to the answer. So what do we have from here?
That's 23.9285.
23 point. 23.928. Yes. So this is our median. So I just want to write out this. So where 8 is the difference between the cumulative frequency, between the cumulative frequency before the median class and the median frequency. No, let me use median frequency and the total total frequency over 2, or half of the total frequency. So that's 8. 8 is the difference between this 17 and this 25. Do you understand? 17 and 25. 17 minus 25 is 8. So that's how we got this 8. Then 14. 14 is the frequency of the median class. 14 is the frequency of the median class. And 6 is the difference in the class, or the number of values, and 6 is the number of values within the class interval. Is the number of values within the class interval.
Okay. And total frequency.
Yes. Total frequency over 2, or you can rewrite it as half of the total frequency. So according to the material, he said, let me quote the material. The result is only approximate, like I've said before, as we have assumed that the 10 values, for this particular example, it was a 10 value that they got. that as against the 14 that we got here, their own was 10. The 10 values in the class are evenly spread. So they assume that this 14, oh, it's even spread between 21 to 26. So that means they all have equal numbers to make this 14. But then in real life, it's not like that. That's just the assumption. So, but in a case whereby it is not evenly spread, that means this answer is wrong. But it's just that it is very close. So this is the best answer that we can get. So next week we will be going to measure of dispersion. And under measure of dispersion, we see range. We'll talk about standard deviation and variance. And that will be all for volume 1. So we'll now talk about volume 2.